All right, calculus. Mr. Lofstrom back again. Here we go with another topic. We are in chapter 1, so we're beginning. We're not to the difference between calculus and pre-calculus yet, but we're getting there. And today we're going to talk a little about one of the major concepts in calculus, and we'll preview it through the eyes of pre-calculus still. All right, and so maybe this is not new to you, but we'll go from there. We're on chapter 1, day 2, and we're talking about functions here. What you see up here is a graph of some possible functions. And remember, the quickest way to check to see if a graph is a function or not is the vertical line test. You have to be careful with that because the vertical line test is an odd test because you're looking for a situation to happen, and when it happens, when the vertical line crosses the graph more than once, then it's not a function. Then it's only a relation. Okay, everybody's related. So if I can find a vertical line, but I got to try all the vertical lines. I can't just try one. Got to try all the possible vertical lines. If I can find one vertical line that crosses the graph twice, and there's a vertical, pretty much a vertical, line that crosses the green graph twice, then it's not a function. So we find what we're looking for, we say, nope, it's not a function. Okay? If I don't find what I'm looking for, then I go, yeah, it's a function. That's an odd way to be defining something. It's a little bit different, but it says that you're going to look for all the vertical lines. If it crosses twice, it's not a function. If it doesn't cross twice, then we're going to call it a function. So this one crossed twice, so we got a problem. This is not a function. Now, right here, it didn't cross at all. We're still okay. Here, once, we're still okay. So what I'd like to do is let's fix this, as we do in math often. That was to illustrate that it's not a function. Now let's fix this and make it a function. So I'm going to do this. Okay? And now we have an idea that all the vertical lines only cross once. It is a function. Notice this is what we would call a piecewise function. It has different pieces. This piece over here in blue is part of a line. This line probably kept going forever, but we stopped it when x was equal to a, which a is probably 0 here as it looks. Okay? Then we have in this region this dark red, purple, no, it's not purple, dark red, okay, maroon kind of, curve, all right? And that goes from A to C, all right? And that's a curve right in there, and there's a piece of a curve that we're showing you. And then I have the green graph, and I have a piece of this. It's another curve, all right? This almost looks parabolic. That does not. Looks more like exponential growth, maybe, or logarithmic. Ooh, probably logarithmic here, okay? And so we have that where it does appear to be 3 different pieces that make this a function. What we're going to do now is we're going to talk about, do we have any regions where this graph is increasing? And so we're going to talk about the intervals where it's increasing and where it's decreasing, and that's going to lead us to this idea of a relative maximum or a relative minimum. Okay? And so as I look here, if I say I want to list off where is the function increasing. Now, you have to be sure when we talk about increasing that you are letting the x's go from the left to the right. I know Arabic goes from right to left, but English goes from left to right. So this is more like English when we're going left to right here, where we go ahead and we start at the left, we go to the right, and then we say, what's the graph doing? So as I go left to right, what did the blue stuff do? Well, it went down, so therefore at that section, it was decreasing. All right? So I'd say the intervals where it's decreasing are when x is less than a. Interval where it's increasing, right here, now as I go left to right, this is going up, so between a and b. Okay? Here, the graph starts to decrease again, the y values start to go down, so that fits into here, and it starts at b, and it does that up until c. Then it has a new region, as I go left to right, this will be increasing, and this goes from c, let's see, c is less than x, no x is greater than c, let's see, where does that stop? Well, there's an arrow at the end, so it doesn't appear to stop ever, we just stop right there. Notice there's 2 sections where it's increasing, and there are 2 sections where it's decreasing. To find a relative maximum or minimum, what you want to do is you want to find a place, a value on the x-axis, along the x-axis here somewhere, where it changes from increasing, the graph is going up, to decreasing, and therefore relative maximum. Or somewhere where it's decreasing, and then all of a sudden it turns around and it is increasing. And so we have 2 places where this is changing. This decreases and then increases, so we would say a, okay? When x equals a, there will be a relative minimum. Now that relative minimum will be the value of the function at a, which we're going to get to later. but there is one when x equals a. There's also a relative maximum when x equals b, and you can see that by it's increasing and now it's decreasing. That makes it a relative maximum. Sometimes students say, but Mr. Lofstrom, what happens if it does this? If it increases and then stays constant and then it decreases. Okay? So here we have an interval, we can call that a, there's b, and we would say that this is increasing as we go from when x is less than a, and it's decreasing when x is greater than b, and we would say this is constant when x is between a and b. Now, for that to be constant, there has to be a region there. It can't just be constant at one point. So some people say they want to say that this is at b it's constant. It's not constant. It was increasing and now it's decreasing. Once in a while, it will increase, and this is what gets students. It'll pause, and then it'll keep increasing. And it's not really pausing because for it to be increasing, every y value, as x gets larger, every y value also gets larger. And so I will be able to say that on this section right here, that as I'm moving here to here, each y value is getting larger. Right at that point at b, we're at a certain height. Because after it, it's always increasing, and before it was increasing, this is going ahead, and it's increasing before b, and it's increasing after b, and right at b, it might not have been necessarily b, but it's not constant, because every single y value, for every x that's bigger, the y value is larger. Okay? So that's not constant. If I have a region, though, if I have an interval where this y value stays the same, that's constant. If you can tell me from here to here, it's always at that same height, well then, every point I go a little bit further, it's not going up, then it's staying constant. But if every point I go a little bit further, it goes up, then it's increasing. If every point I go a little bit further to the right, it goes down, it's decreasing. If it has that one point where it was going down, and now it kind of levels off, but then it goes down afterwards, hey, it's still going to be going down. It's still going to be decreasing. So we get that idea right there. The last thing I want to make sure we talk about is, well, we have both an increasing and decreasing. We should be good. That should be it for the relative maximum. So some books call this a local extrema. Extremas are extremes, so some books will say these are local extremas. Some will call them relative maximums, minimums. Your book usually uses the relative term, but every once in a while you'll see local. So we have a local maximum or local minimum. That's different than a global or overall because it's just not the whole time. Okay, we have a start and stop point. All right, that's half of the lesson. The other half, forget I only have so much time. I better hurry here. The other half is to talk about even and odd functions, describing functions as even or odd. Of course, I forgot to hit the stopwatch, so we'll see here. So if I have an even function, there's a couple things that we know. We know that when I input an opposite of x, I should get the same as f of x. Well, that's the technical speak for that. Let's take a look at points and see what this means. This means that if I have a point xy, and 1, 2 is one of the points, okay, I know right away that if I put in -1, that 2 is also a point. If I have -3 and that's at 5, then +3 is also at 5. If this is an even function, this must happen. If I have 0, 8, okay,